Hi, 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 hi. Good morning, good morning. Hi, good morning. Hi, hi, good morning, good morning, good morning. Good morning. Hi. Hi, good morning. Good morning, good morning, good morning. Yeah. Hi, good morning, good morning. Yeah. Bagunara, bagunara, bagunara. Good morning. Bagunara, bagunara. Very good, very good, very good. Everyone Manchi at home. Bagu Nam sir. Very good, very good. Yeah. So everyone Manchi at home. Full Manchi sir. Very good, very good. So what's going at home? Chilling or studying? Kya ho raha hai ghar pe? What's going on? I am also Manchi. If students are Manchi, teacher is also Manchi. Directly proportional. Directly proportional. Yeah. Chilling with studying, sir. Very good, very good. Sir, we are legends. Normal people chill with sports. Normal people chill with movies and web series. We chill with study, sir. We are ultra pro legend. We are ultra pro legend. Yeah. Is it okay? This week, two exams are there. Yeah, of course, two exams are there. Pace exam is also there. Space exam is also there. Yeah. And yeah, we will chill with gene series. Yeah, okay, okay, no problem. And on Saturday no class is there. Class is only on Friday. Saturday test is there. Because when I came, some of you are asking from Anurag sir. Maybe Anurag sir was not knowing. Yeah. So on Saturday no class is there. On Saturday exam is there, and on Sunday also exam is there. Is it okay? Is it okay? Shall we start with the class? Class shuru kare. Shall we start with the class? Yeah, okay, very good, very good, very good. बहुत बढ़िया, बहुत बढ़िया. And I think in last class we completed horizontal projectile. Is it like that? Is it like that? Horizontal projectile aipoindi. Last class lo horizontal projectile aipoindi. Aipoindi, sir. Very good. बहुत बढ़िया, बहुत बढ़िया. We have completed projectile motion. Yeah. Jagan Anna helicopter was over. Then stuntman problem, I said stuntman jumping. Yeah. Okay. So all those things we completed. Yeah. So we have completed our part in horizontal projection. Today we will move further and we'll start with our next part. We'll start with our, what we have to start? Relative motion. We'll start with relative motion. You can write relative motion. We'll start with part relative motion. Motion of the relatives is known as relative motion. We'll start with our part relative motion. Motion which our relatives perform, that is known as relative motion. Is it okay? Is it okay? The motion which our relatives perform, uncle is our relative. Sometimes he runs, sometimes he walks, sometimes he dances. So that is the motion our uncle perform. So it is relative motion. Is it okay? Is it like that? People are saying okay, sir. Yeah. People are saying okay, sir. Yeah. Okay, okay, no problem, no problem. Yeah. You may be laughing, but actually those who have not studied earlier, yeah, okay, same way I start in juniors right also. The motion of the relative is known as relative motion. So many relatives are in our home, so all the relatives are doing some motion, that is relative motion. You tell me here in relative motion, what is this word relative telling you? What is the meaning of word relative here? What is, yeah, okay, okay, okay. With respect to. Here word relative is not your relative. Here word relative means with respect to. Yeah, okay, no problem. Now we will start. Shall we start? Shuru kare kya? So for 5 minutes, I will give you some idea about relative motion, which will be used slowly in different places. Okay, no problem. Always remember, whenever motion of a body is defined, motion of a body is always defined with respect to observer. Many times we mention, many times we don't mention. That is our problem. But always remember, whenever motion of any body is defined, it is always defined with respect to some observer. And always remember, without observer, motion has no existence. Because if observer is not there, you are performing, you are studying, but if NEET exam is not there, does this study will be useful? You studied, yeah. So always remember, yeah. Whenever motion is defined, motion is always defined with respect to some observer. So that's why motion is always relative. You cannot get absolute motion. Motion of every body in the universe is relative. So you can write this point. You can write this point. Motion is always defined. Motion is always defined with respect to observer. Motion is always defined with respect to observer. Hence, motion is always relative. Motion is always defined with respect to observer. Hence, motion is always relative. So always remember, whenever we talk about any motion, that motion is always defined. Sometimes we mention, sometimes we don't mention. But always remember, motion is always defined with respect to some observer. And without observer, motion has no significance. Motion is always defined with respect to observer. Hence, motion is always relative. And always remember, why we are talking about observer so much? Because a body can have different motion depending on observer. For example, a single body can have infinite number of motion depending on observer. For example, I'll give you simple example. If you are going in train with your father, with your daddy, you are going in train. Train is running with a speed of 100 km per hour. If I ask from your daddy what you are doing, what your son or what your daughter is doing, he will say they are sitting in the train. They are at rest. According to your daddy, you are at rest. But according to someone on the platform, you'll be moving with a speed of 100 km per hour. So that's why observer is very important. That's why every motion is defined with respect to observer. That's why motion is always relative. Is this point is okay for everyone? Is this point is okay? Yeah, okay, no problem. Now. That means, sir, here two things will be there. One will be the object who will perform the motion, and one will be the observer who will observe the motion. You tell me, out of object and observer, who will be having more power? Who will be more powerful, object or observer? Always remember, observer. Object value is 0. Without observer, object do not exist, motion do not. Observer is the most powerful person in entire universe. In entire physics, most powerful person is the observer. Because observer will observe the motion and he will tell you about the motion. If observer don't observe, your motion is useless. So always remember, out of object. So in this part we will get two things. One will be the object who will perform the motion, one will be the observer who will observe the motion. And out of object and observer, observer is the most powerful. For example, I will give you one example which happened to everyone, which happens to everyone. Just here, yeah. For example, you are at home right now. In the morning you started studying. At the same time, yeah, you started studying at that time. Your father wake up early in the morning, he went to the office. For example, early in the morning you started studying from 8 o'clock in the morning, non-stop till 8 o'clock in the night you studied. But 8 o'clock in the night you felt little headache, you wanted some refreshment. Just you came out of your room and you sit on the sofa and just you on the TV. At the same time your daddy came. What your daddy will say? 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 That always, yeah, every day happens. Yeah, this thing happens. This thing happens to everyone. Yeah, this is the bad luck of those who study. Yeah, always. Yeah, he will say, always watching TV. What you will do? You are not serious about yourself. But that is not the reality now. But still, you have to listen to him. Because he's the observer. He's the most powerful person. The person who observes the motion, tells us about the motion, is the observer and is the most powerful person. Yeah, this thing happens to everyone. For me also. When I was a student, for me also this thing used to happen. Okay, no problem. Now be focused. Just here. Yeah. So always remember, when you get the idea now, observer is about to come, always start studying. Always start studying. Okay, no problem. Now be focused. Yeah. Okay, now be focused. So observer is the most powerful person. And always remember, the powerful persons have one tendency. They have one psychology. Always remember, observer, even observer is moving now. He will never feel that he is moving. Observer always treats himself at rest. Or he is the most powerful person, means he is the king of motion. If he is the king of motion, king never move towards people. People move towards the king. So always remember, observer always treat himself at rest. And while treating himself at rest now, he will give his velocity and acceleration. Whatever the motion he has, motion means he will have velocity, he will have acceleration. So while treating himself at rest, he will give his velocity and acceleration in opposite direction to every object motion he will observe. Are you getting this point? You can write this point. You can write this point also. This point itself is complete relative motion. Nothing else is there. Only the thing after this is calculation, only the type of question. But complete relative motion is this line only. You can write this. Observer always treats himself at rest. Observer always treats himself at rest. And he will give, observer always treat himself at rest and he will give his velocity and acceleration. Observer always treat himself at rest and he will give his velocity and acceleration in opposite direction. Observer always treat himself at rest and he will give his velocity and acceleration in opposite direction to the object whose motion he will observe. Observer always treat himself at rest and he will give his velocity and acceleration in opposite direction to the object whose motion he will observe. Everyone has written this line. Everyone has written this line. Once again, you can read by yourself. Once again, you can read by yourself. This is entire, nothing else is there. No other concept is there in relative motion. Observer always treat himself at rest and he will give his velocity and acceleration in opposite direction to object whose motion he will observe. To object whose motion he will observe. And don't be surprised with this statement. Don't be surprised. You have also done the same thing. When you got the chance to become observer, now you have also done the same thing. For example, I will tell you. For example, when you are going in train, if you are going in train, for example, your train is going in the east. When you are going in the train in east direction, when you look out of the window, what you say? Trees are going back. You say trees are going west. Why is that? Does those trees are going back? Does those trees are going back? You are going front. But you are observer, you will not realize that you are observer. Now you will feel that you are actually, what is that? When you look out of the window, you see that all the trees are going back, all the houses are going back, all the mountains are, none of them are going back. You are going front. But since you are observer, you not realize that. This is the power of observer. He treats himself at rest and he will give his velocity in opposite direction to object motion he will observe. Many times happen, your daddy came to drop you at the railway station. At the railway station, before dropping you, he's talking to you near the window where you have the seat. Now suddenly train starts. You start saying, my daddy left behind, my daddy left behind, Papa chhoot gaya, Papa chhoot gaya. Does your daddy left behind? Does your daddy left behind? No, but you say like that. Why you say like that? Why you say like that? You moved front, but you will not say that I moved front. You will say daddy left behind. Because you are observer, you will think that you are at rest. Yeah, you are at rest because you are observer. Yeah. Now, for example, one more last one. Many times you go in a journey, you have to go, for example, if I have to go, for example, if I have to go to Vizag, my home, assume my home is in Vizag. Okay, no problem. I have to go by train. But many times train get late now. So in frustration, people say, now I'm getting late. When Vizag will come, when my home will come, when my home will come. Does my home is coming? Does my home is coming? No. But we say like that. Why? Why we say like that? Kyun? This is the observer mentality. Observer always treat himself at rest. Yeah, we are that time you are observer. You'll think that if I ask from your mom, she will say when my son will come. When my daughter will, she will never say when I will go to the sun. Are you getting the idea? Bolo bolo, done. Basic idea of relative motion. Now how to represent it mathematically? Okay, sir, we understood. Observer will be most powerful person. Observer will always treat himself at rest. For doing this, he will give his velocity and acceleration in opposite direction to the every object motion he will observe, sir. We understood that, sir. But how to represent relative velocity? You write representation. How to represent it, we'll talk. And what is the formula for it? We will talk that also. Yeah. You write representation. I think all of you are knowing, but still we'll talk from the basic. Yeah. So this is how we represent relative velocity. We write like this: VAB. Can you tell me how we'll pronounce it? VAB. VAB, how we'll pronounce it? Velocity of A with respect to B. VAB means velocity of A with respect to B, means A is your object and B is your observer. This is the meaning of VAB. Velocity of A with respect to B. A is the object, B is the observer, and value of VAB will come VA vector minus VB vector. This is the value of VAB. Velocity of A with respect to B. Object is A, observer is B. For example, can you tell me how you pronounce this? VBA. VBA. Velocity of B with respect to A. Now B is object, A is observer, and its value will come VB minus VA. VB minus VA. And from here if you see, you can say simply that, sir, VAB will be equal to minus of VBA. Both are reverse of each other. Value will be same. 4 minus 2 and 2 minus 4, value will be same, only sign will be opposite. So where you can see value will be same. So if you talk in the terms of magnitude, both will have same magnitude. Both will have same magnitude. Done. Bolo. So first you can write basic things we are talking. Okay, no problem. VBA means VAB means velocity of A with respect to B. A is object, B is observer. Its value will be VA vector minus VB vector. Is it okay? Bolo. Now be focused. Achha, does here we use that thing that observer will give his velocity in opposite direction to the object? Does we use that? How this formula came? VAB is Y, VA minus VB. From where it came? It came from that line only. See here. Actually, VAB is not VA minus VB. Dhyan se dekho. VAB is actually, who is object here? You tell me. I'm telling you how this result comes. This will give you more clarity. How to think. Yeah. Who is the object here? A. Who is the observer here? B. What observer do? Observer give his velocity to the object in opposite direction. So what happened? Actually, this VAB is actually, sir, A is the object who has velocity VA. B is the observer. Now what observer do? Observer give his velocity to the object. Who is the object? A is the object. How much velocity A has? VA. He will give observer. B will give his velocity to A. He will give his velocity to the object. You see, he has given his velocity to object. But in which direction? Opposite direction. VA vector minus VB vector. Are you getting the idea? From there this result comes. Observer will give his velocity to object. A already has velocity VA. B will say, I am the observer now. I will give my velocity to you. Already you have VA. I will give my velocity VB, but I will not give in the same direction. I will give minus VB, opposite direction. So it will become VA plus of minus VB, and this will finally give you VA minus VB. Done. Everyone got the idea? Yeah, okay, no problem. Yeah. So observer will give his velocity in opposite direction to every object motion he will observe. Now we'll move slowly towards one part of relative motion. Just see here, yeah. You know, relative motion can happen in two different manner. When the bodies are moving on the same line means they are going either in the same direction either in the same direction or in the opposite direction. This is known as relative motion in, tell me, this is known as relative motion in 1D. 1D. Two things will be possible. If the motion of the bodies are happening on one line only, if the motion of the bodies are happening on one line, that is known as relative motion in 1D. If the motion of the bodies are happening on two different lines, see here for example, see two different lines are involved here now. One body is going up, other body is going east. This is known as relative motion in 2D. First we will talk about relative motion in 1D. You write relative motion in 1D. Relative motion in 1D. Relative motion in 1D. So in 1D, two possibilities will be there. In 1D, if you are talking about sir, relative motion in 1D, two possibilities will be there. Either Manishi version samasya we'll do in the next class, don't worry. Yeah. Relative motion in 1D. So relative motion in 1D means, sir, two possibilities will be there. Either they will be moving in the same direction or they will be moving in opposite direction. So let's take the first situation. Assume two particles are there. Both are going in the same direction with velocity v1 and v2. Here they will ask you what is the magnitude of relative velocity. Can you tell me if they are going in the same direction, what will the relative velocity? V1 minus V2, because you already know now VAB, VA minus VB. So V1 minus V2 or V2 minus V1, depending who is more, who is less. So we'll simply say, sir, if they are going in the same direction, relative velocity will come, sir, V1 minus V2. Magnitude of relative velocity, sir, V1 minus V2. Okay, no problem. And here bodies are going in the same direction. Second possibility is they are moving in 1D, but they are moving opposite to each other. They are moving opposite to each other with velocity v1 and v2. Can you tell me what will be relative velocity here? What is the magnitude of relative velocity now? v1 plus v2. In opposite direction, relative velocity increases. v1 plus v2, that is opposite direction. You can write this. So in the same direction, if two bodies are going in the same direction, relative velocity will become v1 minus v2. v1 minus v2, always remember, means large minus small. Large minus small. So in the same direction, come on, tell me if the two bodies are going in the same direction with respect to v1 and v2, what is the v relative? What is relative velocity? Come on fast. Same direction. Same direction. अरे बोलो, same direction. v1 minus v2, v1 minus v2, v1 minus v2, v1 minus v2. If the bodies are going in opposite direction, what is the relative velocity? Opposite direction, v1 plus v2, v1 plus v2. In the same direction, v1 minus v2. In the opposite direction, v1 plus v2. v1 plus v2. In the same direction, v1 minus v2, opposite direction, v1 plus v2. Achha, is anyone is getting feeling? Sir, formula was VAB is VA minus VB. Sir, here how plus came? Does anyone is getting that feeling? Here, okay, sir, minus came. Here, why plus came? It should be V1 minus V2 now. Anyone is getting feeling? Because of direction. That's why I said you these are vector. This is V1 vector. This is not V2. This is minus V2. You are not changing the formula. Observer is still giving in opposite direction. Don't think formula became VAB is VA vector plus VB vector. No, still it is VA vector minus VB vector. But now VB is negative, opposite now. So you'll say like this, V1 minus of minus V2. That's why it is becoming V1 plus V2 when you are moving in opposite direction. Have you observed this? Have you observed this? In opposite direction, when anyone moves, relative velocity increases. Where you have observed? Where you have observed? Boys observe this thing more. Girls observe less. Yeah, because many times boys will be near the window of the train. They will observe. They will observe. When the train comes from opposite direction, even it is a passenger express. You are in the fastest express. You are in the Shatabdi Express. From there, passenger is also coming from opposite direction. You feel that passenger is moving very fast. You'll be surprised also. Baap re baap, passenger also moves with this. Have you realized this? Boys will realize this more. While driving also, when driving also, you are going in car na, you are going in bike na, when the car comes from other side, you feel that, or baap re, it's coming very fast. It's not coming very fast. Since you are going in opposite direction na, so velocity which you are observing is not the velocity of car. You are observing V1 plus V2. Are you getting the point? Acha, girls are also saying now, girls got on ego, sir. Sir, we are also sitting, we don't sleep in the train, sir. We also see from the window. Okay, no problem, no problem. Don't take on ego. Don't take, but boys go near to the entrance of that also. Acha, you ride bullet also. Oh, very good, yeah. So that's why I said boys observe more, but okay, no problem. Everyone observe, yeah. Okay. Now, so in the same direction, V1 minus V2 in the boys will fly also in the train, yeah. Boys reservation there or not there, same thing. If reservation is there, then still they will roam in the train. If reservation is not there, still they will roam in the train. Yeah, this thing happened for, yeah. Okay, leave it. Yeah, we'll move further. Okay, So, in the same direction, V1 minus V2, in the opposite direction, V1 plus V2. Is this okay? Is this clear? Shall we move towards the numericals? Now from here numericals are asked, and first type of numerical we'll study in the form of topics, so that you'll be able to remember it easily, you'll be able to understand it easily. First type of question is asked, you write crossing of trains. Okay, Gena, yeah. Someone is saying that transgenders also roam in the train. Yeah. Okay, leave it. Okay, now we'll move further. So first type of question which is asked from here is Gagandeep. Yeah, okay. Chalo, theek hai baba. Don't get hurt anyone. Okay. Now, So now first type of question which we are going to, I will provide, no problem. Yeah. First type of question which we are going to talk is related with crossing of two trains. Now just see here what will happen. So crossing, you can write crossing of trains, and just see here first situation. For two trains to cross, only two possibilities will be there. Either both trains are running in the same direction or they are running in opposite direction. So assume two trains are there, they are running in opposite direction with speed V1 and V2. Length of the trains are LL. Can you tell me what will the time taken by them to cross? What is the time of crossing of the trains? What is the time of crossing of the trains? Time of crossing will come distance of crossing by relative. Because together they are crossing. Relative velocity will decide crossing. So distance of crossing by relative velocity. What is distance of crossing? What is the distance of crossing? L by, what is relative velocity? Both are going in opposite direction, Baba. L by relative velocity is what? V1 plus V2. Everyone is getting idea? But this is the mistake that you do. Length of the train will be both length. This is a mistake which students do. They don't read the question. They take L by V1. That's wrong. Crossing of the train means both trains are crossing. That means you have to consider length of both trains. Be careful about this. 2L by V1 plus V2. Easiest question, you'll do mistake. So you have to be careful. For crossing, both trains have to pass each other. Means both trains have to cover their distances. So L plus L, 2L. 2L by relative velocity. Yes, they are going in opposite direction. So effective velocity of crossing, relative velocity of crossing is V1. Are you getting my point? Be careful about there. Small thing, but very big blunder can happen. And why I am saying like this now? Why I am saying like this? Because you should know what is meaning of crossing of train. Crossing of train doesn't mean crossing of you. So see here, crossing of train means, see, this is white train, this is black train. Length L1, L2. Okay, no problem. Yeah, okay. I'll make one train as observer. Let's assume white train needs to be rest. White train as rest. This is our observer. Now, you tell me, This is the instant when crossing starts. Now both trains have started crossing. When the drivers of the train say hi na, that is the instant when crossing start. You tell me here crossing started. Does here crossing completed? Does here crossing completed? Crossing will complete here. Crossing will complete here when the guards of the train will also say bye na, then crossing will crossing will complete. This is starting. This is not అయిపోయింది. Crossing అయిపోయింది లేదు, అక్కడ అయిపోయింది. So that's why L plus L, L1 plus L2. Are you getting the idea? Done. Okay, very good. So that's why be careful about there. I'll give you one question. A simple question you can do. You write, two trains, each of length 100 meter. Two trains, each of length 100 meter, are running on parallel tracks. Two trains, each of length 100 meter, are running on parallel tracks with a speed of 30 meter per second and 20 meter per second. Two trains, each of length 100 meter, are running on parallel tracks with a speed of 30 meter per second and 20 meter per second. Find the time of crossing. Both possibilities are there. They can run on parallel track in the same direction also na, opposite also na. So you cannot say the answer. Yeah, okay. Find the time of crossing if they are running. Find the time of crossing if they are running. Yeah, Ashwak correct. Yeah, Khaja correct. Yeah, Gitika correct. Find the time of crossing if they are running. First you write in same direction. Second, opposite direction. If they are running first in same direction, second in opposite direction. Same direction means 20 will come. Opposite direction means 4 will come. Yeah. Same direction will be more time. Relative velocity is less. It will take more time to cross. That's why it takes more time to overtake the car from the back side. But it takes very easily you can cross the car. Yeah. I'll simply say, sir, first situation you are saying moving in same direction. Same direction means we can find time of crossing, sir. Length will be not one length, sir. Both lengths are moving together. Both trains are there. So we have to consider 2L. So 2 into 100. By relative velocity will become, sir, 30 minus 20. So this will give us 20 seconds. Second situation, they are going in opposite direction, sir. I think everyone got, no problem. Opposite direction means time of crossing will become, sir. Time of crossing will become again distance of crossing 2 into 100 by. Sir, they are going in opposite direction, so V1 plus V2. So 30 plus 20, that will come, sir, 50. So 200 by 50, that will give us 4 seconds. Done. Bolo. Aipoindi. Easy. This is also previous year NEET question only. So many questions are asked. Simple question. Yeah. Same direction, opposite direction, you can do very easily. Achha, you tell me. In place of train, in place of two train, assume one bird is flying over the train. Then where will be the change? Bird flying against the train or in the same direction of train, what will be the change? Now 12 you don't have to consider, because size of bird will be negligible. Size of the bird will be negligible in comparison to train. You have to only consider length of train. You write the question. Only one L will come. Now 2L will not come. Two trains are there. That's why you are getting L plus L. But if train and bird is there, bird is negligible in comparison to train. So only length of train will come. This previous year NEET question. You write. In the given figure, I am giving you in the terms of figure. Because I draw very nice diagram, you already know. In offline lecture, I have practiced train diagram. This is what they taught me. Yeah. Okay. So this train is given. Yeah. Thank you, Aswak. Yeah. Train is given length of 50 meter. And this train is running with speed of 15 meter per second. And there is a bird. Recently, just now I learned how to draw the bird. Oh, nice. Really nice. Yeah. The best bird I'm drawing till now. Yeah. Bird is going against the train with 10 meters per second. You have to tell me time of crossing. Yeah, Ashwak, correct. Very good. Everyone can do here. No need to here take 100. Acha, that one duck. This is not duck. This is bird. Come on. Yeah. So I'll simply say, sir, what is the total distance for crossing 50? And what is the velocity of crossing 15 plus 10? That is, yeah, they are going in opposite direction. So relative velocity will become V1 plus V2. V1 plus V2. अरे बाबा पागल हो गए हो क्या? हाउ संध्या, हाउ यू आर सेइंग 10 सेकंड? देखो यार, कम ऑन, आंख खोल के कम से कम एक बार देख तो लो. They are in opposite direction. कैसे करते हो? They are going in. Can't you see the arrow? So total distance of crossing, bird size negligible. So train 50 and relative velocity. Relative velocity of crossing is 15 plus 10. That is 25. So time of crossing will come 2 seconds. Is it okay? Basic, simple question. Now correct. Yeah. Is it okay? Okay, very good, very good. I'm giving you time of 2 seconds. See all this situation. We'll move further. We'll talk about some more questions from here. Once you complete, you can say done, sir. And once I will say done, sir, start saying done, sir. Okay, no problem. Very good, very good. Now understand. Yeah, okay, very good. बहुत बढ़िया. Now just see here. Yeah, okay, Now, one type of question I am going to tell, and I will tell you in the form of topic, because I've seen the students struggle. They keep on thinking G plus A, G minus A. So if I will tell you in the very famous question, if I will tell you in the form of topic now, you'll be able to revise properly. You'll be able to remember properly. You'll be able to understand properly. There we will talk about, you have seen a lift question, where they will say you one coin is dropped in the lift going up, down, find time, find relative acceleration with respect to lift, with respect to ground. Have you seen those questions? So we'll talk about those questions with clarity. You can write, and yeah. And here we will talk about relative. Here we'll talk about acceleration. The way for velocity, I'm saying that if the velocities are in the same direction, v1 minus v2, velocities are in opposite direction, v1 plus v2, same thing you can use for acceleration also, because differentiating that velocity is only getting acceleration. So if two bodies have acceleration in the same direction, you write relative acceleration a1 minus a2. If the two bodies have acceleration in opposite direction, come on, tell me how to write acceleration. If the two bodies have accelerations in opposite direction, how much acceleration you'll write? Opposite direction accelerations a1 plus a2. Acceleration in the same direction a1 minus. Everyone is getting idea? Same thing you'll use for acceleration. Why same thing we will use for acceleration? Bolo. Why we will use the same thing for acceleration? Because how acceleration comes when you differentiate that velocity, then only acceleration comes now. So if velocity is v1 plus v2 for the same direction, acceleration will be also a1 plus a2. If velocity is v1 plus v2 for opposite direction, acceleration will be also a1 plus a2 for opposite direction. This is okay? You write? Yeah, you write relative acceleration in lift. This is not a topic, but I'm converting this question in the form of topic to give you more clarity. Relative acceleration in a lift. Relative acceleration in a lift. Now see here, two possibilities lift will have. Lift may be going upward or lift may be coming downward. Both possibilities we will talk, nothing to worry. Yeah. So, toughest diagram to draw in this entire universe is to draw the lift, in which I am perfect, which I draw very perfectly. This is the lift. Yeah. Okay. Easiest thing to draw is to draw a lift. Box bana do. Box bana do. Okay, no problem. Now just see. Dabba. Just make a dabba. You'll get. Now, now just see here. Now just see here. Now, here what will happen? Here what will happen? Here they will say. So let's assume. Let's assume. Now be focused here. Let's assume. Let's assume we have a lift. This lift is going upward. Two possibilities are there. First we'll discuss upward, then downward you will be able to do by yourself only. Nothing to worry. Yeah. So first we'll talk, sir. Let's assume there is a lift. This lift is going upward with an acceleration A. And here we will talk with respect to two observers. One observer who is already there in the lift. Or we will say with respect to lift. With respect to lift. Yeah. Observer in the lift means if lift is going with A, observer is also going with same acceleration A. This is the first situation. There is a lift is going upward with an acceleration A, so there is an observer inside the lift. This observer is also going with same acceleration A. Second is observer on the ground. Observer on the ground. If lift is going with A, this observer is also going with same acceleration A. And what will be the acceleration of the observer on the ground? What will the acceleration of observer on the ground? Its acceleration will be 0. Its acceleration will be 0. So lift going up, observer in the lift also going upward with an acceleration A. One observer is on the ground, two observers we are going to talk. One observer is on the ground. Now understand. Now someone says, sir, in the lift, if a coin is dropped, once you drop, the instant you will drop, this coin will have acceleration due to gravity G. They will say you, once the lift started, one coin is dropped in the lift. Once you drop the coin, can you tell me what will be the acceleration of the coin itself? How much acceleration coin will have? And if you drop anything, how much acceleration that thing has? It will have acceleration G. Yeah. So acceleration of the coin is G. Now you have to tell me with respect to lift, how much observer in the lift will observe the acceleration. What is the acceleration of coin with respect to lift? Opposite direction na dekho, aankh khol ke dekho, both are in opposite direction. This is A upward, this is G downward. Just now you study in opposite direction, V1 plus V2. In the same manner, A1 plus A2. So with respect to lift, acceleration will be G plus A. And with respect to ground, tell me with respect to ground, acceleration of coin with respect to ground, tell me how much this will come. This will come same as G. Because its acceleration is 0 na. Ground acceleration is 0 na. So G plus 0 or G minus 0. Two possibilities are only there na. G plus A or G minus A. So G plus 0 or G minus 0. It will give you G only. Done. Chamka, everyone got with 100% clarity? Very good. Sir, very simple. Sir, once you drop the coin will itself have acceleration due to gravity downward. If lift is going upward, both are in opposite direction. In opposite direction, we know sir, A1 plus A2, so G plus A. Sir, ground 0. So with respect to ground, either G plus 0 or G minus 0, same value G will come. Now, if you understood this, tell me the second one. Now, second one I will not tell. Same coin dropped, but now lift is going down with an acceleration A. Can you tell me what is the acceleration of the coin with respect to lift? With respect to lift, bolo. G minus A. Now you can see both are in the same direction downward. So acceleration of the coin will be now G minus A with respect to lift. And what is the acceleration of the coin with respect to ground? With respect to ground, it will be still G. It will be still G because ground is at rest, so it will see the actual acceleration, that is G. Bolo, done. Yeah. And this is the conceptual question which is asked. One numerical is also asked. I will talk about that numerical also. Yeah, okay, no problem. Huh? So without seeing the notes, without seeing anything, without drawing diagram, can you imagine? Yeah, can you imagine and tell me directly, if the lift is going upward, what will be its what will the acceleration of the coin drop with respect to the lift itself? Upward na, and this G will be downward na. So up and down opposite na, G plus A. G plus A. With respect to ground, G, sir. A plus G plus 0 or G minus 0, it will remain G. Achha, if lift is going down, sir. So lift down, coin G also